A-level statistics, displaying data, cumulative frequency graphs. Now let's see what we mean by a cumulative frequency graph. If we've got some grouped continuous data, we can display it on a cumulative frequency graph. Let's have a look at an example. Suppose 60 children were given a puzzle to complete, and they were timed to see how long it took. Their times, measured in seconds, were recorded in the following table. We can see that all the children finished within 60 seconds, within a minute. Now we can draw a cumulative frequency graph. What we need to do is complete a third column called the cumulative frequency. The cumulative frequency on any row is equal to the sum of all the frequencies on that row and above. So for example, on the third row, the frequency is 23 and the frequencies above are 10 and 4. So the cumulative frequency is 23 plus 10 plus 4, which is equal to 37. So the cumulative frequency in each row is the number of children that took less time than the upper limit of that group. In other words, on row 3, 37 children took less time than 30 seconds. So in the first row, 4 children took less than 10 seconds. In the second row, 14 children took less than 20 seconds. And in the third row, 37 children took less than 30 seconds. Now in each case, to get the next number, we add the number above and the number to the left of the one we want. If we add the numbers 37 and 14, we get 51. If we add the numbers 51 and 5, we get the number 56. And if we add the numbers 56 and 4, we get 60. And now we can plot those points on the graph. We plot each of the times with the number of children who took less than that time. If we look back to the column labelled groups, we see there are 6 rows, but there are actually 7 different numbers in that column, starting with 0 and then 10, 20, 30, 40, 50 and 60. So we're going to plot 7 points starting at 0. Now there were no children with a time less than 0, so the first point we plot is 0, 0. And then in each case we plot the cumulative frequency with the upper limit for the time. So we plot the point 10, 4, we plot the point 20, 14, then 30, 37, 40, 51, 50, 56 and 60, 60. So this gives us each of the times plotted against the number of children that took less than that time. Now we have a choice. We can join the points using straight lines, in which case this is called a cumulative frequency polygon. Or alternatively, we can join the points using a smooth curve, in which case this is called a cumulative frequency curve. Now there's no particular advantage of one over the other. If you're specifically asked to draw a cumulative frequency polygon, then you should use straight lines. If you're specifically asked to draw a cumulative frequency curve, then you should draw it as a curve. But if you're asked to draw a cumulative frequency graph, you can choose whichever you prefer. It's probably easier to draw it with straight lines, because using a ruler it looks much neater. Drawing it with a curve is harder because you have to draw it freehand. Now we can use this graph to see how many children took less than a given time. So if we find 30 children on the y-axis and then look across to the curve and down, we get 26.8. That means 30 children take less than 26.8 seconds. If we find 35 seconds on the x-axis and then look up to the curve and across, we get 45.2 children. In other words, 45 children took less than 35 seconds. Let's look at another example. The following table shows the heights of 100 Christmas trees in a tree nursery. In part 1, we're asked to complete the table and draw a cumulative frequency graph of the tree heights. Well, to solve this, we must first complete the cumulative frequency column. In the first row, the cumulative frequency is 8. There are 8 trees below the height 0.6. Now to get the next cumulative frequency, we add the 8 above with the 7 to the side to get 15. We then add the 15 with the 8 to get 23. We add 23 with the 9 to get 32. We add 32 with 19 to get 51. We add 51 with 21 to get 72. We add 72 with 19 to get 91. And we add 91 with 9 to get 100. We can check we've done the addition right because we know we should end up at 100 Christmas trees. Now if we look at the groups column, we see there are 8 rows, but there are actually 9 different heights. It starts at 0.4 and then goes 0.6 up to 2. We must not forget the point 0.4. Now it's a good idea to circle it to show that there are no trees with a height less than 0.4. We can now draw the graph. The x-axis shows the heights of the trees, and they start at 0.4 going up to 2. Because we're not starting at 0, we can draw a zigzag line to show that the values of x between 0 and 0.4 are compressed. The y-axis shows the number of trees, and that goes from 0 to 100. Now to plot the points, we're plotting the upper limit of the height in the group column with the cumulative frequency. And remember, we've got the point 0.40. Then we have 0.68, 0.815, 1.023, 1.232, 1.451, 1.672, 1.891 and 2.0 100. We can then join the points with either a straight line or a smooth curve. And that's our graph. Now you might wonder which is better, to draw it with straight lines or to draw it with a curve. Actually, neither is particularly accurate. If we were to use the raw data for the heights of the trees, then we could actually draw an exact copy of what the cumulative frequency curve should look like. We see that it does not look like a curve or a polygon. In fact, it looks quite random, but does go through the given points. Now if we go back to our original graph, in part 2 we're asked, if only trees taller than 90 centimetres can be sold, estimate how many saleable trees there are at present. Now, if we find 0.9 on the x-axis, that is a height of 0.9 metres, and then look up to the curve and across, we see it comes out to be 18.8. That is 18.8 or 19 trees. So there are 19 trees less than 90 centimetres, which means there are 81 trees above 0.9 metres. In part 3, we're asked if the 20 tallest trees were sold, estimate the maximum height of the remaining trees. Well, if we find 80 on the y-axis, and then look across to the curve and down, that comes out at 1.7. So that means the 80 remaining trees have a maximum height of 1.7 metres. So all the remaining trees are below 1.7 metres. Now in part 4, we're asked to estimate how many trees there are between 110 and 150 centimetres tall. Well, if we find 1.1 on the x-axis and draw up and across, we find that it comes to 27 trees. So there are 27 trees below a height of 1.1. Now if we find 1.5 on the x-axis and look up and across, that comes out to 61.5 trees. So the number of trees between them are 61.5 minus 27, which is 34.5 trees, which means the total number of trees between the two heights is 34.